Have you ever looked out of an airplane window high above the clouds and wished the journey could be just as fast as your excitement to arrive? Not fast in the way a modern jet takes you across continents in 8 or 10 hours, but fast enough that you'd sip your coffee somewhere over the Atlantic, and by the time it's still warm, you'd already be landing in Europe. That idea, flying at nearly twice the speed of sound, wrapped in the comfort of a luxurious business cabin, is no longer just a nostalgic dream from the Concorde days. It's a promise being made again, and this time it comes with a name that's been making aviation lovers hold their breath: Boom Overture. By 2026, Boom says its supersonic jet will take passengers at Mach 1.7, that's over 1,300 miles per hour, and cross the Atlantic in about 3.5 hours, not in cramped conditions. Not with the rattling noise of early supersonic experiments, but in a cabin designed for the kind of people who value both speed and experience. The ones who see flying not just as transportation, but as an event worth remembering. Now here's the real hook. This video isn't just about what the Boom Overture promises. It's about the deeper question that aviation fans can't stop debating: is this business cabin something we will actually step into in just a few years? Or is it a vision that belongs more to the realm of glossy brochures and futuristic renderings? Stay with me until the end of this video, because if you do, you'll not only know the answer, you'll also learn a fascinating truth about how our minds react to the future of aviation, and why some designs spark more passion than others. That's your reward for sticking through this journey, insight that will change the way you look at every aircraft concept from this moment on. Let's rewind the story for a moment. The world last tasted commercial supersonic travel more than 20 years ago when Concorde, the elegant white dart of the skies, made its final landing. For many aviation lovers, that day felt like the closing of a chapter that would never be reopened. Supersonic travel was an engineering marvel, yes, but it came with high-ticket prices, deafening noise, and fuel consumption that didn't fit into a changing world. And yet, the fascination never faded. Because for people who truly love airplanes, speed is not just a number, it's a feeling. It's the rush of acceleration down the runway, the hum of the engines climbing into thinner air, the knowledge that you're outrunning the rotation of the Earth's surface. Boom Supersonic knows this psychology well. That's why their 2026 business cabin concept doesn't just talk about velocity, it talks about experience. They are marketing speed not as a bare utilitarian metric, but as luxury in motion, a place where comfort, design, and technology work together so seamlessly that passengers forget the physics happening outside their panoramic windows. And let's be honest, that's the hook that gets the aviation heart beating faster. We are wired to respond not only to efficiency, but to elegance. Psychologists have long understood that when humans imagine the future, we tend to picture not just improved function, but improved beauty. That's why renderings of the Boom Overture cabin are bathed in soft lighting, with generous legroom, and seats that feel more like personal lounges than rows of transportation. But here's the question that deserves to be asked. When we see those images, the clean lines, the airy spaces, the perfect window views, are we seeing an honest preview of reality? Or are we seeing a vision crafted to speak directly to the deepest desires of airplane lovers, knowing that in the human brain, desire often outruns doubt? The answer, like the aircraft itself, moves fast and changes altitude. Because on one hand, technology has leapt forward since the days of Concorde: lighter composite materials, quieter engines, advanced aerodynamics, and sustainable aviation fuels that can reduce the environmental cost. On the other hand, history has taught us that the jump from concept to certified aircraft is a long, turbulent climb, one that can strip away many of the luxuries promised at the start. And yet, that tension between dream and reality is exactly what makes this moment in aviation so intoxicating. If you're someone who tracks aircraft announcements the way others follow sports scores, you know the thrill of a big reveal, the press releases, the artist renderings, the carefully chosen technical stats that make your imagination take flight. That's what Boom Overture is tapping into. They're not just building a plane, they're building anticipation. They're feeding a hunger in the aviation community that has been left unsatisfied for 2 decades. And they're doing it with a promise that's hard to resist: a business cabin that gives you both speed and serenity. So as we begin this journey into the details of the Boom Overture 2026 business cabin, remember this: every airplane ever built began as a sketch, a pitch, and a promise. Some of those promises took flight, some never left the runway. By the end of this video, you'll know which side this aircraft is more likely to land on. And maybe, just maybe, you'll feel that same old thrill that first made you fall in love with airplanes. The thrill of looking at the horizon and imagining what could be. When Boom speaks about the Overture's business cabin, They're not just listing features, they're painting a picture, one designed to light up the imagination of anyone who's ever pressed their forehead against a plane window, watching the world pass beneath them. The concept begins with space, not just the absence of a neighbor's elbow, but the feeling that you're in your own private environment at 60,000 feet. Boom's early designs show wide seats that angle toward the panoramic windows larger than what you'd find on most commercial jets today. This is deliberate. In aviation psychology, the window isn't just for light, it's for connection. It's a reminder that you are moving faster than almost anything else on Earth, and yet still tethered to the beauty below. Then there's the sound, or rather the lack of it. Supersonic flight has always been associated with noise, both inside and outside the cabin. But Boom claims its Overture cabin will be engineered for quiet comfort, using advanced insulation and engine placement to reduce cabin noise to levels comparable with subsonic business class. If true, it would be more than a technical achievement. It would change the mental image people have of what supersonic feels like. Lighting is another element they emphasize. Not harsh overhead fluorescence, but a human-centric lighting system that shifts throughout the flight, tuned to the circadian rhythms of passengers. Airlines have learned over the last decade that lighting can help reduce jet lag, and Boom appears determined to make that science part of the cabin's DNA. For business travelers crossing oceans in half the usual time, that could mean arriving not just earlier but genuinely more refreshed. The seating itself blends familiarity with ambition. The layouts appear to borrow from current long-haul business class designs: privacy shells, fully reclining beds, generous personal space, but with a sharper, more streamlined aesthetic. Every curve and angle seems designed to reinforce the idea of speed, even when you're perfectly still. That's not an accident. Studies in environmental psychology show that design shapes perception. A space that feels fast makes the journey feel faster. One of the most intriguing aspects Boom hints at is personalized service integration. The business cabin would have technology embedded in the seat environment, allowing passengers to control lighting, temperature, and even service requests without leaving their seat or summoning a crew member in the traditional way. This is part of a larger trend in aviation toward passenger autonomy, and it aligns perfectly with the Overture's narrative. You're in control, even in an environment moving at 1,300 miles per hour. From a branding standpoint, this is a masterstroke. It's not just getting there quicker, it's giving the passenger a sense of mastery over the journey. For aviation lovers, that psychological edge matters, because the allure of flight has always been about control over the elements, about bending time and distance to human will. The cabin also promises elevated dining experiences. While Concorde was famous for its champagne and caviar, Boom seems to be framing its meal service around modern luxury. Fresh ingredients, lighter menus tailored to the reduced flight time, and possibly partnerships with well-known chefs. There's a subtle psychological move here as well, making the experience about quality, not quantity. Supersonic passengers won't be looking for endless in-flight courses. They'll be looking for something memorable in the short window between takeoff and landing. And then, of course, there's the symbolism of the design language itself. Renderings show clean lines, pale neutral tones, and accent lighting that makes the cabin feel both futuristic and inviting. The absence of visual clutter is deliberate. It communicates efficiency, sophistication, and progress. Research in consumer psychology has shown that minimalism in design often signals advanced technology, even if the passenger doesn't consciously notice it. But perhaps the most powerful part of Boom's vision is what's not on the specification sheet: the emotional promise. The Overture's business cabin is designed to evoke a sense of belonging to an exclusive era of travel, one that vanished with Concorde's final flight. To step into that cabin would be to step into a living piece of aviation history, except this time with the promise of sustainability and modern comfort. This plays directly into the psychology of scarcity. Supersonic flight is rare. Very few humans will ever experience it, at least in the near term. That rarity turns every detail of the cabin into something precious. The stitching on the seat, the feel of the armrest controls, the way the light hits the window at Mach 1.7. For the passenger, these become more than features. They become proof that they've joined an elite chapter in aviation's story. Of course, this is still the vision stage. No cabin mock-up, no matter how detailed, can fully capture the reality of building, certifying, and operating a supersonic business class in today's commercial aviation market. But that's not the point. Not yet. Right now, Boom's business cabin exists as an idea that people can fall in love with. And if there's one thing aviation history has taught us, it's that falling in love with an idea can be the most powerful fuel of all. Passengers don't book flights because they've calculated thrust-to-weight ratios or studied wing-loading charts. They book because they've imagined themselves in a seat, looking out at the curve of the Earth, and they want that moment badly enough to pay for it. Boom's marketing team understands this down to the smallest detail. Every element they show, from the seating angle to the view through the oversized windows, is aimed at a specific emotional target to make you feel like you're already there. And for people who live and breathe airplanes, that feeling can be irresistible. The Overture's business cabin, as it's presented today, is more than just a promise of faster travel. It's a psychological experience in the making. A deliberate blend of nostalgia, exclusivity, and design that makes the aviation heart beat faster. Whether this vision will hold up when the aircraft takes its first commercial flight, that's another matter entirely. But for now, Boom has given airplane lovers something rare. A believable dream of the skies, reborn at supersonic speed. Dreams in aviation are never built in the clouds. They are forged in wind tunnels, test flights, engineering labs, and endless safety reviews. For all the beauty and promise of the Boom Overture's business cabin, there is a harder truth running beneath the surface. Turning a supersonic vision into a certified, reliable, and profitable aircraft is one of the most challenging feats in modern transportation. The first challenge is physics itself, flying at Mach 1.7 is not a simple matter of increasing engine power. At these speeds, every surface of the aircraft is under enormous aerodynamic stress. Air molecules behave differently. Shock waves form along the fuselage, and materials must withstand constant heating from air friction. For a business cabin to remain quiet and comfortable at that velocity, the engineering must solve problems that even Concorde in all its glory never fully mastered. Noise is one of the most stubborn of these problems. Supersonic engines inevitably produce intense sound levels, both in the cabin and in the form of the sonic boom outside. Boom has claimed its Overture will meet or exceed the strictest noise standards, but doing so without sacrificing thrust, efficiency, or passenger comfort is a delicate balancing act. In the aviation world, every decibel reduced often comes at the cost of weight, complexity, or performance. Then there is fuel, the lifeblood of any aircraft. Supersonic travel burns significantly more fuel per passenger than subsonic jets, simply because pushing through the air at such speeds requires far greater energy. Boom intends to run the Overture entirely on sustainable aviation fuel, SAF, which can reduce life cycle carbon emissions by up to 80%. The environmental benefit is clear, but the economic challenge remains. SAF is currently far more expensive and less widely available than conventional jet fuel. To make the Overture's ticket prices competitive, the supply chain for SAF would need to expand rapidly, something that's not in the direct control of any single aircraft manufacturer. Cost was one of the major factors that grounded Concorde. Its tickets were priced beyond the reach of most travelers, and while that exclusivity gave it prestige, it also limited its market. Boom is aiming for a business-class price point. High, but not astronomical. Still, the math must work. That means every element of the Overture's design has to balance luxury with operational efficiency. If the aircraft can't fly full or near full, profitability collapses. And profitability isn't just a corporate goal. It's the difference between an aviation revolution and another beautiful idea that never reached scale. Regulation adds another layer of complexity. Supersonic passenger travel over land is currently banned in many countries due to sonic boom noise pollution. While Boom's marketing focuses on transoceanic routes, gaining permissions, proving safety, and meeting global environmental standards will involve years of collaboration with authorities like the FAA and EASA. Certification processes for entirely new aircraft types can be notoriously slow and costly. Even a small design change during testing can set schedules back by months, sometimes years. Inside the cabin, the challenge is psychological as well as technical. Passenger comfort at supersonic speeds is not guaranteed just because the seat is luxurious. Rapid acceleration, higher cruising altitudes, and the subtle but constant vibration of high-speed flight can affect the body in ways subsonic passengers rarely notice. Engineers will need to design seating, lighting, and climate systems that keep passengers physically and mentally at ease throughout the journey. If comfort fails, repeat business disappears. Weight is another relentless constraint. Every feature in that business cabin, from wide seats to sound insulation, adds mass. In supersonic flight, extra weight is the enemy of range, fuel efficiency, and speed. Designers are therefore in a constant tug-of-war between the indulgence of the passenger experience and the strict diet demanded by the laws of aerodynamics. Concorde was a marvel, but even it carried only about 100 passengers with almost no cargo, because the weight penalty of going faster was so severe. Boom will have to navigate the same razor-thin margins. There's also the question of reliability. Modern travelers are used to a certain level of dependability in commercial aviation. But when you operate a cutting-edge aircraft at extreme speeds, maintenance requirements can be far more demanding. Components wear faster, tolerances are tighter, and turnaround times between flights may be longer than those of conventional jets. For a business cabin to feel premium, delays and cancellations must be kept to a minimum. Yet that's exactly where experimental technology often stumbles in its early years. History offers a sobering reminder: the gap between prototype and production is where many ambitious aircraft have met their end. Beautifully engineered concepts have failed because the cost per flight was too high, the maintenance schedule too punishing, or the market too narrow. In each case, the dream didn't fail because it wasn't inspiring. It failed because it couldn't survive the real-world economics and logistics of aviation. And yet, this is also where the fascination deepens. For airplane lovers, part of the thrill is watching a machine like the Overture navigate these challenges. There's an understanding that true progress in aviation is always won against resistance, against the limits of materials, the strictness of regulators, and the physics of our atmosphere. The Overture is not just an aircraft, it's a test of whether 21st century engineering can solve the problems that 20th century marvels could not. If Boom succeeds, the reward is monumental. A quiet, comfortable supersonic business cabin would not just resurrect an era of travel long thought extinct, it would redefine what is possible in global mobility. It would make the world feel smaller in a way that's tangible, personal, and exhilarating. But if they fail, the Overture may join the long list of aircraft that promise to change everything, only to become a footnote in aviation history, a reminder that the sky does not yield its secrets easily. For now, the business cabin exists as a promise, balanced on the edge of possibility. To turn that promise into reality, Boom must prove that speed, comfort, sustainability, and profitability can all fly together. The history of flight says that's a steep climb. But as any pilot knows, the most rewarding views are found at the highest altitudes. Every great leap in aviation has started as something unbelievable. The Wright brothers' Fragile Flyer was once dismissed as a curiosity. The first jet-powered passenger planes were met with skepticism. Concorde was called impractical before it became an icon. The Boom Overture stands in that same charged space between disbelief and breakthrough, the moment when the future of flight is still deciding whether it will take off or fade into a blueprint. The optimism around the Overture is not just technical, it's emotional. Boom is presenting more than a machine. It's presenting a narrative of return, the return of supersonic travel, this time shaped by the lessons of the past. They are telling a story of speed without the harshness, of exclusivity without isolation, of sustainability without sacrifice. For airplane lovers, that combination is magnetic because it speaks to the deep-seated belief that technology should not only move us faster, but move us better. From a purely technical standpoint, the timing is more favorable than it was in the Concorde era. Material science has advanced dramatically. Carbon composites are lighter and stronger than the aluminum alloys of the past. Engine technology has made efficiency gains unthinkable 2 decades ago. Computer modeling allows engineers to predict airflow, noise patterns, and structural stresses with precision Concorde's designers could only dream about. Environmental awareness, once an obstacle, is now driving innovation. The industry's push towards sustainable aviation fuels is aligning with Boom's stated goal of running the Overture entirely on SAF. If the supply chain grows as projected, this could blunt one of the sharpest criticisms of supersonic travel: its environmental footprint. There's also a generational factor. The last time a passenger could buy a ticket for a supersonic flight was in 2003. That means there's an entire generation of travelers who have never experienced it. For them, the Overture's promise isn't a nostalgic revival, it's something entirely new. That novelty has value. In consumer psychology, scarcity and uniqueness create desire. A supersonic seat, especially in a refined business cabin, would be one of the rarest travel experiences money can buy. Yet, even with all these favorable wins, the path ahead is narrow. The technical, economic, and regulatory challenges outlined earlier are not just minor turbulence. They are weather systems that could ground the aircraft before it ever boards its first passenger. The gap between a design concept and a commercially operating fleet is enormous. Boom must not only build the Overture, it must prove it can be flown reliably, profitably, and within global environmental standards. For the business cabin, the stakes are even higher. Passengers paying a premium price for speed will not tolerate compromises in comfort or service. Every detail, from cabin pressure to seat ergonomics to onboard dining, must meet the expectations set by the renderings. The moment the actual experience feels less than the promise, the psychological spell is broken. Supersonic flight is a luxury, and luxury is as much about perception as performance.